In this video we're going to introduce the very important idea of logarithms. To begin with, I just need you to recall all of the different rules of indices. In particular, we need to remember that a to the p times a to the q equals a to the p plus q, that a to the p divided by a to the q is the same thing as a to the p minus q, that a to the p raised to the power n is the same thing as a to the n times p. We need to remember that a to the naught gives me 1, that a to the minus n is the same thing as 1 over a to the n. We need to remember that a to the 1 over p is the same thing as the pth root of a, and that a to the q over p can be conveniently thought of as being a to the 1 over p raised to the power q. In other words, it's the pth root of a raised to the power q. Okay, now let's move on to looking at logarithms. The basic idea of a logarithm is simply that a logarithm statement is a slightly different way of writing a statement about indices. So, if we know that x is a to the power p, then that enables me to write down straight away that log to base a of x is equal to p. So the statement x equals a to the p is equivalent to the statement log to base a of x equals p. Another way of saying it is that log to base a of x is the power of a that gives us x. So saying that x equals a to the power p is the same thing as saying the logarithm to base a of x is p, and we sometimes abbreviate the word logarithm down to just the word log. So we say the log to base a of x is p. So the fact that we know that 81 is the same thing as 3 to the power 4 means that I can say that log to base 3 of 81 is equal to 4. The fact that 1 125th is the same thing as 1 over 5 cubed, which is 5 to the minus 3, can be written as log to base 5 of 1 125th is minus 3. The fact that 4 is the cube root of 64, which is 64 to the power 1/3, means that we can write log to base 64 of 4 is 1/3. If I know log to base 7 of x is 2, that means that x is 7 to the power 2, which is of course 49. If I know log to base 2 of y is minus 3, then that means that y must be 2 to the minus 3, which is 1 over 2 cubed, which is 1/8. So for example 1, we first of all got to obtain the value of log to base 6 of 36. So I need to write 36 as a power of 6. Well, I know that 36 is the same thing as 6 squared. So that tells me that log to base 6 of 36 must equal 2. For the second part, to find log to base 3 of 1/9, I need to write 1/9 as a power of 3. Well, I know that 9 is the same thing as 3 squared, so 1 over 9 is 1 over 3 squared. 1 over 3 squared is the same thing as 3 to the minus 2. So that tells me that log to base 3 of 1/9 is minus 2. For part C, I need to find log to base 2 of 4 root 2. Now I know 4 is the same thing as 2 squared. I know that root 2 is the same thing as 2 to the power of half. So I can say that 4 root 2 is 2 squared times by 2 to the half, which is the same thing as 2 to the 2.5. In other words, 2 to the 2.5. Because if I'm multiplying 2 squared by 2.5, I've got to add the powers. So I know that 4 root 2 is 2 to the 2.5, so I can say that the log to base 2 of 4 root 2 is 2.5. For part D, I know that 1 over 7 root 7 is the same thing as 1 over 7 to the power 1 times by 7 to the half. 7 to the power 1 times 7 to the half is going to be 7 to the 1.5. So 1 over 7 root 7 is going to be the same thing as 1 over 7 to the 1.5. In other words, it's going to be 7 to the minus 1.5. That now means that I can say that log to base 7 of 1 over 7 root 7 is equal to minus 1.5. For example 2, we're going to try and find the log to base 2 of 11. Now unfortunately I don't know 11 as a power of 2, but I can use my calculator to do a trial and improvement method on it. So let's suppose that log to base 2 of 11 is p. That means I'm trying to solve the equation 11 equals 2 to the p. So if I have p equals 3, I know that 2 to the p is 8. On the other hand, if I have p equals 4, I know that 2 to the 4 is 16. So the value of p that I'm looking for is going to be somewhere between 3 and 4. Let's try 3.5 at this stage. So using my calculator, 2 to the 3.5 is 11.31. That's a little bit too big. So I now know that the value of p is somewhere between 3 and 3.5. Let's try 3.4 at this stage. If I have 2 to the power 3.4, my calculator tells me that's 10.55, which is a bit too small. So I now know the value of p that I'm looking for is somewhere between 3.4 and 3.5. Let's go for the middle value again. So if we go for 3.45, 2 to the power 3.45 is 10.92. So if I try 3.46, I get 2 to the power 3.46 is 11.004. So we now know that the value of p that I'm looking for is somewhere between 3.45 and 3.46. If I now use a test value of 3.455 and calculate the value of 2 to the 3.455, I get 10.966. So I now know that the value of p that I'm looking for lies between 3.455 and 3.46. Now any such number that lies between 3.455 and 3.46 rounds to 2 decimal places to 3.46. So to 2 decimal places, I know that p, or the logarithm to base 2 of 11, must be 3.46. Now we will find later in this video a much quicker means of calculating the value of log to base 2 of 11. For the next example then, we're going to try and solve the equation log to base 4 of y equals 2.5. Well, if I've got log to base 4 of y equals 2.5, that means that y must equal 4 to the power of 2.5, which is the same thing as 4 to the 2 times by 4 to the half. Of course, 2 and a half is the same thing as 2 plus a half, so I'm just using the rules of indices there again. 4 squared is 16. 4 to the half is the square root of 4, which is 2. So I've got y is 16 times by the square root of 4, or 2, which gives me 32. So y must be 32. For part B, if I know that log to base 5 of 6y plus 5 is equal to 3, then that means that I know that 6y plus 5 must be the same thing as 5 to the power of 3. 5 to the power of 3 is 5 times 5 times 5, which is 125. So I've got 6y plus 5 must equal 125. So 6y equals 120, and y must therefore be 20. Now there's some important shorthand involved with logarithms. The first one is if we write just log x, that is the shorthand for log to base 10 of x. If I write ln x, that's the commonly used shorthand for log to base e of x, which is called the natural logarithm of x. Now your calculator will have at least 2 logarithm functions on it. If we look at, for instance, at the fx83, the 3 are very easy to find. If we look in that top hand corner there, the first one we can see gives us the logarithm to any base. Then we've got the value of the natural logarithm, that's log to base e of x, is the ln button, and the log button gives us the value of log to base 10 of the number that we input. On the FX991, which many of you will probably have, it's easy to find the ln button and the log to any base buttons. The log function can be accessed either by using the shift button followed by the minus button, or of course, and possibly easier, is to use the log to any base button and use 10 as the base. Historically speaking, logs to base 10 were used to offer a really important means of doing complicated multiplication, division and power calculations without spending hours carrying out formal long multiplication and division sums. So if you ask your grandparents about how they used to do calculations before calculators were available, they would have almost certainly have said, oh, I think we did something with logarithms or slide rules, which were tools that used logarithms. So, just to finish off, we'll check for people who've got the FX991 or the ClassWiz machine that we can actually use our calculator to find the logarithm to base 2 of 11 to begin with. So we press the log to any base, tell it the base is 2, and then put the number in, which is 11. And we get the logarithm to base 2 of 11 is 3.4594 ... Log to base 10 of 0.216, very much the same calculation, put 10 in as the base and then put the number 0.216 into the brackets. So that's minus 0.6655. And then finally the natural logarithm of 75. We use the natural logarithm button, put the number in, and it doesn't matter if you don't close the brackets off in this case. And we get 4.317. So in this video we've introduced logarithms. We'll be seeing a lot more about logarithms in subsequent videos.